Here we want to beat the portfolio in B, which is half A and half B, with the same return, lower risk. So on a diagram, suppose we have A here, B here, and this frontier looks like that, and our optimal, or the market, this is the market portfolio, this is risk-free. So what we want to do here is half A, half B, suppose it's here, it really should not be. So suppose it's somewhere here, half A, half B, then what we want is we want to use this optimal one combined with risk-free one to get something that has the same return but smaller risk. So let's try to do that. So the condition is the return must be the same. So let's invest in Y in the market one and 1 minus Y in the risk-free one. So our return of our new portfolio, this is P, let's say P star, is Y times the return of the market, which is 0.08, 1 minus Y times the return of the risk-free. And this portfolio must have the same return as the one from B, which is half one. And we computed this 0.124. So from this equation we can already solve, so we don't need the other one. So we can solve for Y to be 2.1, and then the sigma P star squared is just Y squared times the sigma market squared, which is 2.1 squared times 0.1 squared. So sigma P star is equal to 0.21. And sigma P from part 2 has smaller risk, so this is larger. So it means if we want to use a combination between optimal and risk-free, we get something that's more risky. So that's why the answer is no, cannot beat the thing we get in part B. So why is that? So from this diagram, obviously it's not possible, but remember from part part A, B is overpriced. Is B overpriced or underpriced? So B is, let's say, mispriced from part A. So mispriced means B does not actually is priced according to CAPM, so it's mispriced according to CAPM. So that is the reason why it's possible that we cannot actually use the optimal one and the risk-free one to beat a combination between A and B. So answer is no.